We've all seen the headlines, right? Industry 4.0, it's everywhere. But what's really going on beneath the surface? Today we're doing a deep dive, looking at our sources to get past those, buzzwords. We want to uncover the surprising stuff, the transformations that are, genuinely reshaping global industry.
Exactly. And for those of you who already kind of get the basics, our mission here is really to peel back the layers. We want to extract those less obvious nuggets of knowledge, the kind of understanding you only get when you really look closely at the latest research and what's happening on the ground.
Okay, so if you've heard Industry 4.0 being talked about, maybe think of it less like just another upgrade. It's more like a complete shift in how things get designed, made, delivered.
It really is. It's about creating these deeply interconnected ecosystems.
Yeah, where machines, data, even the products themselves, they're all communicating autonomously, making decisions.
Precisely, making informed decisions in real time. And our sources, they consistently point out this huge shift is driven by that convergence, of advanced tech.
Like artificial intelligence, the Internet of Things.
Right, AI, IoT, and that sophisticated cloud computing infrastructure holding it all together.
We're moving past simple automation then, into something more like genuine smart factories.
That's the core idea,
Yeah.
where every single element is part of a network that's constantly optimizing itself. And it's not just about being faster or cheaper, though that's part of it. It's about unprecedented adaptability, precision.
Okay, so this future is kind of already here in many ways. How do we start to unpack it? In this deep dive, maybe first we should dissect the core technologies, the building blocks that make Industry 4.0 actually possible.
Good idea. Then we can explore the tangible benefits, what these systems actually deliver.
Right, and look at some compelling real-world examples maybe. See it in action. And we should also talk honestly about the challenges, because it's not all smooth sailing.
Definitely not. And finally, we can, cast an eye towards the future, see where this evolution is heading.
Sounds like a plan. And as we navigate all this, maybe you, the listener, can think about what resonates, what implications pop up for your own field or interests.
Yeah, absolutely. And what's really fascinating is how these technologies, which might seem separate, actually weave together. So first up, you mentioned the Internet of Things, IoT.
Right.
And it's way beyond just connecting devices.
Right.
In Industry 4.0, it's really about embedding intelligence directly into the operational assets, the machines, the tools.
So intelligence in the machines.
Think of it like pervasive sensor networks. They're gathering super granular data from every single corner of a factory floor. This gives you real-time monitoring, incredible visibility into processes. Our sources really stress how this helps shift operations from being reactive to predictive.
That shift, reactive to predictive, that sounds powerful. But with all that data, this absolute torrent of information, what do we actually do with it? That's where big data and analytics come in, I guess. But it's not just about collecting it, is it?
Not at all. The sources we looked at illustrate it's about applying really advanced analytical models to massive, diverse data sets. The goal is to reveal patterns you wouldn't normally see, anticipate when things might go wrong, and even prescribe the best actions to take.
So moving beyond just describing what happened to diagnosing why and even prescribing what to do next.
Exactly. Diagnostic and prescriptive insights. And the engine that really powers those prescriptive capabilities. That's artificial intelligence and machine learning.
Okay, AI and ML.
Yeah, and these aren't just like smart assistants. They're the algorithms that let systems learn directly from data. They can spot anomalies, make autonomous decisions that are context-aware, all without needing explicit step-by-step programming for every scenario.
Can you give an example?
Sure. Think about quality control. AI-powered vision systems, for instance. They can spot microscopic defects in products moving at incredible speeds. And crucially, they learn. They adapt to new types of defects in real time. That's far beyond what a human inspector could consistently do.
That level of autonomous decision-making.
Right.
Yeah, that's a huge leap. Okay, and then there's something called cyber-physical systems, CPS.
Right, CPS. This is really where the digital world stops just informing the physical world and starts actively controlling it.
Actively controlling.
Yeah. Our sources explain CPS as these intelligent networked systems. They monitor physical processes like temperature or pressure. Then they create a digital twin, a virtual representation. And here's the key bit. They use that digital insight to make decentralized decisions and trigger physical adjustments.
So it's like a closed loop. Digital monitors physical, digital decides physical changes.
Exactly. It's that closed loop feedback that turns a collection of smart devices into a truly intelligent, responsive factory. Not just smart sensors, but smart action.
Got it. But handling all that data, especially making decisions in real time, the
Yeah.
sheer volume and speed must be immense.
It is. And that's where cloud and edge computing become critical. Cloud computing gives you that scalable backbone for data storage, heavy processing, running applications, huge flexibility, especially for global operations.
Okay, the cloud provides the scale.
But for Industry 4.0, what's often even more critical is edge computing.
Edge computing, processing data closer to the source.
Precisely. Processing data right there at the machine, or very close by. This massively cuts down latency with delay. And for time-sensitive operations like controlling a robot arm or adjusting a process parameter instantly, that reduction is essential. Milliseconds matter in these autonomous systems.
Okay, that makes sense. Edge for speed, cloud for scale. And building on that integration, that link between digital and physical, our sources talked a lot about digital twins. Now, this isn't just a 3D model, right? It's more dynamic.
Much more. A digital twin is a dynamic, real-time virtual replica of a physical asset, like a specific machine, or even a whole processor system. It's continuously updated with live data streaming from its physical counterpart.
Continuously updated. So what does that let you do?
Well, it opens up incredible possibilities. Predictive maintenance, for one. You can see signs of wear or potential failure in the twin before it happens in reality. You can optimize performance by testing changes on the twin first. Run what-if scenarios without risking the actual operation. It's like having a living blueprint that predicts the future.
A living blueprint. I like that. Okay, and rounding out these sort of foundational pieces, we have autonomous robots.
Right, and again, these are a big step up from the traditional industrial robots bolted to the floor doing one repetitive task.
How so?
Our research highlights they're becoming much more dexterous, capable of finer movements. They're more collaborative, designed to work safely alongside human workers. They can navigate complex, dynamic environments, like a busy warehouse floor. And through AI, they can learn new tasks, adapt to changing production needs. It adds dramatic flexibility to manufacturing.
Okay, so we've got IoT, big data, AML, CPS, cloud edge, digital twins, autonomous robots. Quite a toolkit. But why should you listening care about all this tech? How does it translate into real benefits? I mean, our sources must cover the why bother part.
Oh, absolutely. Businesses aren't doing this just for the tech. The core benefit, the one everyone talks about first, is a huge uplift in operational efficiency.
Efficiency, like less downtime.
Exactly. Machines that can self-diagnose problems. Systems that schedule their own maintenance predictively before something breaks. That dramatically cuts unplanned downtime, and it optimizes throughput, how much you can produce.
Makes sense. What else?
Well, connecting this to the bigger picture, it also means a dramatic improvement in product quality and consistency. When you have continuous monitoring and AI making micro adjustments on the fly, you don't just detect defects, you often prevent them from happening in the first place.
Preventing defects, not just finding them later.
And there's resource utilization too. Smart systems are incredibly efficient. They lead to pretty substantial reductions in energy use, water consumption, material waste, which is great for the planet, obviously, but it also delivers significant cost savings. It hits the bottom line.
Right, efficiency, quality, sustainability. And for businesses trying to stay ahead, what about agility? Being able to respond quickly.
That's huge. Industry 4.0 enables unprecedented agility and, crucially, the capability for mass customization.
Mass customization, making personalized products efficiently.
Exactly. Our sources detail how these flexible systems allow production lines to be reconfigured rapidly, almost on the fly. So you can actually manufacture personalized or highly varied products economically. It's a massive shift away from the old one-size-fits-all mass production model, and that directly impacts how responsive you can be to market trends, to individual customer demands.
Okay, so this isn't just theoretical. You mentioned real-world examples. Where are we seeing this stuff making a difference already?
Oh, it's deeply embedded in quite a few sectors now. Take advanced automotive manufacturing, for example. You see autonomous mobile robots, AMRs. They're not just simple carts moving parts. They're dynamically rerouting themselves based on real-time production needs, even navigating around people on the factory floor. It massively optimizes how materials flow.
Okay. What about something like pharmaceuticals?
Another great example, AI and IoT are really transforming drug development and quality control there. You've got smart sensors monitoring critical environmental conditions, temperature, humidity in labs and production suites, 24/7. Meanwhile, AI algorithms are crunching complex molecular data to speed up drug discovery. We're talking about potentially shaving months, even years, off development cycles.
Wow, years. That's significant.
Definitely. And even in, say, the food and beverage industry, we're seeing much better end-to-end supply chain visibility. Smart sensors, tracking products right from the farm, through processing to the store shelf, ensuring optimal freshness, cutting down on spoilage, and enhancing traceability. If there's ever a safety issue, you can recall products much faster and more precisely.
Right, so it's touching a lot of different areas, but you mentioned challenges earlier. It can't all be easy.
No, absolutely not. While the potential is enormous, the transition isn't trivial. A major hurdle, often the first one companies hit, is the initial capital investment. These integrated, sophisticated systems, they require significant upfront spending. That can be a real barrier, especially for smaller businesses.
The cost factor. Okay, what else?
Well, think about all that interconnectedness we talked about. That creates a much larger attack surface for cybersecurity threats. Protecting sensitive operational data, ensuring the integrity of these control systems, it becomes absolutely paramount. And it's complex.
Cybersecurity, yeah, that's a big one.
And then there's the people side. The critical need for workforce reskilling, maybe even upskilling. The jobs within an Industry 4.0 environment require different competencies. It's less about manual labor, more about data analysis, system management, working with collaborative robots.
So training and adapting the workforce is key.
Absolutely. And one more big technical challenge is integration. How do you connect these cutting-edge Industry 4.0 solutions with existing older systems, legacy equipment? Those older systems often weren't designed for this level of connectivity. So integration requires careful planning, sometimes custom development work. Yeah, it can be tricky.
Right, integrating the new with the old.
But, our sources do emphasize that these hurdles are being overcome. Companies that are pioneering this, they're navigating these challenges with strategic planning, often taking a phased approach, not trying to do everything at once.
Okay, so it's challenging but manageable with the right strategy. Looking ahead then, where does this go next? Is Industry 4.0 the end state?
I don't think anyone sees it as the end state. It's more like a major waypoint on an ongoing journey of technological evolution. The source material points towards even more advanced technologies coming into play. Think about next generation wireless like 5G or even 6G eventually, enabling ultra-reliable, low-latency communication on a massive scale.
Lower latency, more connections.
Exactly. Or quantum computing potentially solving optimization problems that are completely intractable today. And the accelerating integration of sustainable energy solutions directly into industrial processes. It suggests our industries will just keep getting smarter, more agile, more resilient. It's a continuous dynamic evolution, really.
So to kind of wrap things up, Industry 4.0, it's fundamentally reshaping how things get made globally. It's turning these isolated processes into intelligent, interconnected, self-optimizing ecosystems.
Right. It's not just about bolting on some new tech. It's really a whole new philosophy, a new way of thinking about and running industrial operations.
And its relevance is incredibly broad, isn't it? Whether you're, running a business, working in tech R&D, or honestly, just curious about where the future's heading.
Industry 4.0 is something everyone probably needs to pay some attention to, because it's actively shaping the world we're all going to live and work in tomorrow.
That is incredibly compelling stuff. It really makes you think. And, remember what some sources say, the future isn't something that just happens to us. It's something we actively help create. So maybe the final thought for you listening is, what does all this mean for you? How might you get involved, be part of this pretty amazing transformation that's underway?